Today, we are conducting a serious, sequential technical review of the Vertex AI architecture based on the provided slides. Our objective for you, the listener, is to conduct a strict analysis of the platform's mechanics.
Right. It's a peer-to-peer technical exchange. We are just looking at the architectural data, stripping away any marketing noise.
Exactly. So let's start directly with slide 1, Mastering the Machine Learning Lifecycle. The intent here is to establish a unified workflow.
Correct. This slide details how this covers everything from data ingestion straight through to serving. It unifies various expertise levels and essentially connects pipeline steps that are typically highly fragmented.
Which brings us to slide 2, the universal need versus the fragmented reality. This defines the primary business driver for the architecture.
It does. The data extracted here shows that all modern applications require data predictions, but the varying expertise levels create severe bottlenecks.
I mean, fragmented tools basically stall innovation.
Precisely.
Moving on to slide 3, Vertex AI. This outlines the platform's core value proposition.
Yes, it presents a singular environment, one that accommodates every skill level, model type, and stage of growth. You aren't constantly migrating as your operations scale.
Understood.
Hmm.
Let's look at slide 4, the universal ML workflow. The intent here is standardizing the process.
The standardization breaks down into 4 distinct phases. First, prepare data. Second, train model. Then, evaluate and optimize. And finally, deploy and predict.
A strict operational sequence. Let's dig into that sequence with slide 5, step 1, data preparation. This covers the ingestion mechanics.
Right, so the platform imports image, tabular, text, and video data. It creates what they define as a managed data set.
And you don't have to switch context for refinement, right?
Correct. It allows in-UI refinement and labeling. You do it all without leaving the primary environment.
Efficient. On to slide 6, step 2, model training. Here we are looking at execution pathways.
The text contrasts 2 specific pathways: AutoML, which is a zero-code, minimal-effort approach, and then custom models, which are utilized for entirely bespoke architectures.
That leads directly to slide 7, diagnostic matrix. Training pathways. I have an analytical question here based on the slide. Does choosing custom training fundamentally break the unified ecosystem?
No, the documentation clarifies it does not. AutoML handles standard formats and edge devices, sure, but custom training seamlessly supports TensorFlow, PyTorch, and scikit-learn.
So it still heavily supports deep technical teams.
Precisely. It keeps them in the same ecosystem.
Slide 8, the custom environment ecosystem. This details the architectural layers for those teams.
Right. It outlines notebooks, pre-built containers, and custom Docker containers. Plus, it highlights hardware accelerators specifically for hyperparameter tuning.
Which is critical for optimizing performance. Moving to slide 9, step 3, evaluate and optimize. This focuses on pre-deployment validation.
Yes, it assesses overall model efficiency. Crucially, it utilizes explainable AI to reveal the exact data signals that are driving the predictions.
So it eliminates the traditional black box problem entirely.
Exactly. You see the exact factors influencing the output before you ever go live.
Slide 10, step 4, serving the model via endpoints. This is the live architecture.
Correct. Endpoints are used for live predictions. The slide details traffic management splitting, auto-scaling compute nodes, and direct cloud logging observability.
Let's drill into the specific deployment strategies on slide 11, deployment paradigms. This contrasts latency versus volume strategies.
Online deployment requires those auto-scaling endpoints for low latency. Conversely, batch uses undeployed models.
Reading asynchronously.
Yes, reading asynchronously directly from cloud storage to handle high volume.
Slide 12, blueprint of the control center. This gives us the UI physicalization of everything we've discussed.
The centralized dashboard directly maps to that workflow. It integrates datasets, notebooks, and training models and endpoints into one unified view.
Slide 13, the Vertex AI advantage. This serves as the architectural summary.
It distills down to 3 core points: a unified pipeline in a single pane, universal flexibility, and automatically scalable infrastructure.
Finally, slide 14, what is your ML use case? This outlines the immediate next steps for you, the listener.
The infrastructure is clearly ready. The text notes that you must now define your specific prediction task and prepare your dataset.
Right. So as we conclude this technical review, I want to leave you with a final analytical consideration. As you standardize on a unified platform like Vertex AI, eliminating manual infrastructure provisioning, how will that fundamentally shift your team's focus from mere maintenance to pure predictive innovation?